So let's say I've written a little C program to print out the words hello world, and I've saved it in a file called hello.c. How do I actually run this program? If I just try running the .c file, that's not going to work. The computer's not going to treat it as a C program like I intended. It turns out that even though C code looks pretty cryptic at first, it's still not low level enough for computers to understand it. Before you can run C code on a computer, you first need to compile it, which transforms your C code into machine code, which, as its name implies, is a binary format that the machine can understand. The easiest way to do this is to just use a command called make. Make is a utility for compiling source code. It's not a compiler itself, but rather a program that organizes invocations of the compiler on source code files so that things get compiled in the proper order and in the proper way, since compiler flags can get kind of complicated, as we'll see. It's particularly helpful when you're working with large projects with lots of source code files and many different libraries, but it's also nice to use it when you're just working with a single file. So let's compile this Hello World program using make. The name of my source code file is hello.c, so I'll type make hello, and make will use its default setup to compile it. Assuming all goes well, I can use the ls command to list all of the files in the directory, and I should see a new file called hello. This file is called an executable, and it's in the binary format that the computer can understand. If we open it up, we can see some characters that we can understand, but for the most part, it's just a bunch of mumbo jumbo. However, I can run this file and watch it print out hello world over and over again. Oh, the excitement. So let's go back a bit to our make command and see what actually happened in order to produce the executable file. You can see that when I ran make, it printed out this line beginning with Clang and ending with hello. This is make invoking the compiler, in this case, one called Clang, with a bunch of default flags or options in order to produce our executable. Clang is one of a number of C compilers out there in the world. You might have heard of or used other ones, particularly one called GCC that is especially common. We've chosen to use Clang in CS50 because we think it does a really good job of providing helpful warnings and error messages, and because using it is really similar to using GCC, so you can pretty easily switch between the two. When make ran Clang, it ran it with a whole bunch of options. However, it's not necessary to use all of those options to just compile a single .c source code file. All I need to do is use Clang hello.c. Again, if all goes well, this produces an executable file. However, if I try running ./hello, I get an error saying that there's no such file or directory. What happened? Clang, by default, names its executables a.out, which we see if we list the directory with ls. This file we can run, and it will also print out hello world as intended. If we want to rename the executable, we can use the move command to do so. But most of the time, we just want Clang to do the proper naming for us. We can do this with the -o flag. If I run Clang hello.c-o hello, then I'll get an executable named hello. The -o option is super common, so expect to see and use it a lot. The next Clang options that you'll see a lot of begin with -w. These options control what kinds of warnings Clang gives you about your code. For example, Clang can warn you if you declare a variable that's never used. If I put an int variable called x in hello.c and then compile with Clang -w unused -variable hello.c-o hello, Clang warns me about this unused variable in my code. Now, there are a ton of different warning types, and it would be obnoxious to have to list them all out when you run Clang. Instead, there's a shortcut option to turn them all on, -w all. We have this turned on by default when you run make in the appliance, so you get all of the warnings that Clang can give you about your code. In general, having your code produce compilation warnings is not a good thing, and we'll expect the programs that you write for CS50 to be warning-free. However, as you see, Clang will still produce an executable file, even if there are warnings during the compilation process. We can, however, force Clang to stop compilation and produce an error if it encounters something worthy of a warning in the code. We do this with the -w error option. Now, if I compile my hello.c file with the unused int variable x, I won't get an executable file. Now, I can't ignore compilation warnings. I need to go fix my code. Another important option is -g gdb. This enables special debugging information in the executable file so that I can run the debugger, gdb, on my program if it crashes. Without this option, I can't access much of my program's information within gdb, like variable and function names, so it's important to include -g gdb too. When you run make on the appliance, this option is also included by default. The final option that it's important to know about is -l, which is used to link libraries into your code. For example, if you want to use functions from the CS50 library, like getString, you need to make sure that not only do you pound include the library's header file, cs50.h, in your .c source code file, but also that you use -lcs50 when compiling, so that the library's implementation is linked with your program. Let's change the Hello World program to prompt the user for a name with the getString function, and then use the name in our hello string. Now, if we try to compile this program without using -lcs50, we get an error about an undefined reference to getString. Uh-oh. Let's add in -lcs50, and now everything works just fine. One gotcha is that it does make a difference where in the command you write -lcs50. If I write it before I write hello.c, then the CS50 library is loaded and processed before my source code. So it's as if I didn't write -lcs50 at all. As a rule of thumb, you'll generally want to put all of your -l options at the end of your command. So now, let's put it all together. Clang -g gdb -wall -w error hello.c -lcs50 -o hello. That's a lot of stuff. That's why make is so helpful. It takes care of all of that for you. So now you've got a good idea of what goes into compiling your code. My name is Nate Hardison. This is CS50.